Hey there, this is Dr. Rishi from the Learners Academy. Today we are going to go ahead and dive deeper into trigonometry. Today we are going to talk about trigonometric ratios of specific angles. This topic is taught in 10th standard CBSE, 9th standard ICSE and 10th standard state boards. Now the specific angles that we are going to choose are 0 degrees, 30 degrees, 60 degrees, 90 degrees and 45 degrees. These are the 5 angles whose specific ratios we need to know. They have specific values and they are generally written in a tabular format. How we arrive to these values is a very technical thing. However, what we need to know are these values. So today in this video, we are going to talk about how to find these values, or rather how to write them in the tabular form, and not actually how we derive these values, because this I think is what is more important and would be more useful for you people. After the explanation, we are also going to discuss some examples from each of the 3 boards. This topic is also important for another topic that is used a lot in trigonometry. The topic is termed as heights and distances, where we find heights of objects or distances of the objects from a particular point using trigonometry. Yes, this is the same concept that is there that we are going to use to say find the diameter of the sun or the distance of sun from earth. So without losing any time, let us go ahead and see how we can draw this table in less than 2 minutes. This table is very crucial, and in case of stressful situations, you can always scribble this table on your rough sheet and get the required value. So let's go ahead and start writing this table. Now first thing we are going to do is we are going to draw an empty table, and then I'm going to teach you a small trick which we can use to remember all the values. So let us go ahead and have our 6 ratios written. So first I have sine theta, then cos theta, then tan theta, then cot theta, then sec theta, then cosec theta. Now I am going to need 5 ratios. I am going to find 5 ratios or ratios of 5 different angles. So first is 0 degrees, second is 30 degrees, then we have 45 degrees, then we have 60 degrees, and the last one we have is 90 degrees. Now we have the empty table in front of us. Apart from this, what all things are we going to need? So we are going to need 2 simple formulas, that is tan theta is equal to sine theta upon cos theta. We arrived at this formula in our first session, so in case you don't remember it, please go back and check that. And the other formula that we need is sec theta is equal to 1 upon cos theta. We have our table ready for us. We have the required 2 formulas that are there. Now we are going to go ahead and write all the values of these 5 different angles. So totally we have 30 values that we can deduce. Now the trick goes like this. We write number 0, 1, 2, 3 and 4 at the top. Divide these numbers by 4. And take a square root of it. So 0 divided by 4 is 0. Square root of a 0 is 0. Square root of 1 by 4 is 1 by 2. square root of 2 by 4 is 1 by root 2. Square root of 3 by 4 is root 3 by 2. And square root of 4 by 4 would be 1. Square root of 1, so it would be 1. So these are our sine ratios, or the values of sine. So this is sine 0, sine 30, sine 45, sine 60 and sine 90. Now in the previous video we have also talked about one more concept, that is the ratios of complementary angles. So the ratios of complementary angles are exactly same. It would mean that cos 0 would be 1 because sine 90 is 1. Cos 30 would be equal to sine 60. Cos 45 would be equal to sine 45. Cos 60 would be equal to sine 30, and cos 90 will be equal to sine 0. Now we can use these two ratios using this formula to get our tan value. So tan 0 would be sine 0 upon cos 0, so it would be 0 upon 1, so it would be 0. This would be 1 by root 2, so I will do it here. 1 by 2 divided by root 3 by 2. It effectively is 1 by 2 multiplied by 2 by root 3. 2's get cancelled and we are left with 1 by root 3. So this is 1 by root 3. Now 1 by 2, root 2 divided by 1 by root 2, same numbers are dividing each other, so we can write the answer as 1, and this answer can be written as root 3. Here it would be 1 divided by a 0. So if we have any number divided by 0, the final answer is not defined. So we'll write this answer as not defined or infinity. We prefer writing not defined. Now for cot, it would be exactly similar to cos. So we have not defined, that is the value of tan 90 would come at cot 0. The value of tan 60 would come at cot 30. The value of tan 45 and cot 45 would be same, and then we have the value of cot 60 would be equal to the value of tan 30, and cot 90 is going to be equal to 0. Now let's go ahead and talk about the values for sec theta. As we know, sec is reciprocal of cos theta. So I take cos theta and I take a reciprocal of it. So I end up with cos 0 would be 1, cos 30 would be 2 by root 3, cos 45 would be root 2, cos 60 would be 2, and cos 90 would again be not defined because the reciprocal of 0 is not defined. Same way we can go ahead with cosec and write not defined at 0, 2 at cosec 30, root 2 at cosec 45, 2 by root 3 at cosec 60, and 1 at cosec 90. Now, what are other things that we can see from this table? If you look at the values of sine and cos, we can say that the value of sine goes from 0 to 1. So in case it so happens that your value for sine is larger than 1 or smaller than minus 1. Now I'm being very specific here, larger than 1 or smaller than minus 1. Then there is something drastically wrong, because sine cannot have value above 1 or below minus 1. Now, can trigonometric ratios have negative values? Yes, they can. However, we would be learning it in our 11th standard. That is out of the scope for the time being, so we will stick to the positive values only. So for the time being, sine can take values between 0 to 1, cos can take values between 0 to 1, so 0 to 1, tan can take any value that is there above 0. So is true with cot. Sec is slightly complicated. It cannot take a value less than 0. So if you'd see, all the values for sec are greater than 0. None of the values is less than all the values for sec are greater than 1. None of them are less than 1. And same is true for cosec theta. So to summarize it, these are the 30 values that we get, and we have also checked out that if it is sine and cos, the value should be between 0 to 1. If it's tan and cot, the values can be 0 to infinity, and if it is sec and cosec, the values cannot be less than 0. In case it so happens that you are doing some sum and the value for your sine theta or cos theta is above 1, you need to recheck your calculations. If the tan value, we don't have to worry about tan value because it can take all values that are there. Sec value, if it is between 0 and 1, yes, you need to reconsider your calculation because there might be an error. Let us consider an example where sine 30 degrees minus sine 90 degrees plus cos 0 degrees divided by tan 30 degrees multiplied by tan 60 degrees. We have to solve this example, so let's see. Now, in this given example, we have sine 30 degrees minus sine 90 degrees plus cos 0 degrees divided by tan 30 degrees multiplied by tan 60 degrees. So what we do, we go ahead and we write the values that we calculated in the table a few minutes back. So we have sine 30 degrees, that was half, minus sine 90 degrees, that was 1, plus 2 multiplied by cos of 0 degrees, so that was 1. The whole thing divided by tan of 30 degrees, which was 1 by root 3 multiplied by tan of 60 degrees, which was root 3. And we get the final answer as this gets cancelled with this, and we have half minus 1 plus 2, giving us half plus 1. This whole thing gets divided by 1, so I have not written it down, which would be equal to 1.5 or 3 by 2. And this is our final answer. This is a relatively easy sum. This is sum number 2 from chapter number 23, Trigonometric Ratios, in ICSE 9th standard concise Selena book. Now, the next question that we are going to talk about is exercise 23A from Selena concise book for mathematics for 9th standard ICSE. This is sub question 5 of question 3. The question is tan 60 degrees plus 1 upon tan 60 degrees minus 1 square is equal to 1 plus 30 degrees upon 1 plus cos 30 degrees upon 1 minus cos 30 degrees. Now, the sum says tan 60 degrees plus 1 upon tan 60 degrees minus 1 square is equal to 1 plus cos 30 degrees upon 1 minus cos 30 degrees. These kind of sums, we have to prove that the left hand side is equal to the right hand side. So when we do these kind of sums, we are going to solve the left hand side separately and then the right hand side separately, and then we are going to go ahead and say that the left hand side is equal to the right hand side. So let us start with the left hand side first. So we have the left hand side is equal to tan 60 degrees plus 1 upon tan 60 degrees minus 1 square. So it is equal to root 3 plus 1 upon root 3 minus 1 square. So when I square it, I get, so I can separately square them out, and I will get root 3 square plus 1 square plus 2 times root 3 divided by root 3 square plus 1 square minus 2 root 3, giving me, so root 3 square is 3 and 1 square is 1, so it would be 4 plus 2 root 3 upon 4 minus 2 root 3. I can take 2 common in both the cases and have 2 times 2 plus root 3 upon 2 times 2 minus root 3, giving me 2 plus root 3 upon 2 minus root 3. I would further rationalize the denominator by multiplying it by, so this would be 2 plus root 3, and it would get multiplied by 2 minus root 3 because we are rationalizing the denominator, and in the denominator we have, we multiplied by 2 plus root 3 to rationalize the denominator, and we have 2 minus root 3 multiplied by 2 plus root 3. We'll use the identity a square, a minus b multiplied by a plus b, as a square is equal to a square minus b square here, and get the final answer as, so the numerator is square of the same number, so it is 2 plus root 3 square upon, here we will have 2 square minus root 3 square, so that would be 2 plus root 3 square upon 4 minus 3, so that is equal to 2 plus root 3 square divided by 1, or simply 2 plus root 3 square. So this was our left hand side. So I will write my left hand side here for the further reference, and we can erase the board and go with solving the right hand side. In your case, you'll name it as statement 1, and then it would be easier for you to equate statement 1 to statement 2. So we have our statement here, root 3, statement 1 here, 2 plus root 3 square is equal to the first statement, that is equal to my right hand side. Now I'm going, that is equal to my left hand side. Now I'm going to talk about my left hand side. My left hand side is equal to 1 plus cos 30 degrees upon 1 minus cos 30 degrees. So my values here are 1 plus root 3 by 2 upon 1 minus root 3 by 2. Since the denominators are not same, I'll have to make their denominators same. So I'll get 2 upon 2 plus root 3 by 2 divided by 2 upon 2 minus root 3 by 2, giving me the final answer as 2 plus root 3 by 2 divided by 2 minus root 3 by 2. So that is further equal to 2 plus root 3 divided by 2 multiplied by 2 divided by 2 minus root 3. So since we have to divide two fractions, we basically multiplied by the reciprocal of the denominator. These two gets cancelled, and we are left with 2 plus root 3 divided by 2 minus root 3. Now we have to rationalize this as well to get our final answer. So we will have to multiply it by 2 plus root 3 multiplied by 2 minus root 3 divided by, 2 plus root 3 multiplied by 2 plus root 3, and the denominator gets multiplied by 2 minus root 3 multiplied by 2 plus root 3, giving the final answer as 2 plus root 3 square divided by 2 square minus root 3 square. So that's 2 plus root 3 square divided by 4 minus 3, giving the final answer as 2 plus root 3 square upon 4 minus 3 is 1. So we can simply write it as 2 plus root 3, the whole thing square. This is my statement 2. So from statement 1 and statement 2, we can say that LHS is equal to the RHS, and we'll write this in brackets from 1 and 2. There are multiple extra steps that I have done in this particular sum. That is, we could have just equated these two and said that they are equal. However, when we talk about pure mathematics, we never have denominator as an irrational number. That is the only reason I have converted a completely irrational denominator into a rational number, into an irrational number in the numerator, and the denominator is rationalized. So from 1 and 2, we can say that my left hand side is equal to my right hand side. This was an example from ICSE. Now we've done 2 examples from ICSE. Let us go ahead quickly and do an example from the NCERT book, which is prescribed by CBSE. Now we are going to talk about an example from NCERT book. This is an old book. I have the older version of the book. This is exercise 8.2, question 1, sub question 5. The example is like this: 5 cos square 60 degrees plus 4 sec square 30 degrees minus tan square 45 degrees upon sine square 30 degrees plus cos square 30 degrees. We have to find value of this equation. So let's go ahead. So the example is 5 cos square 60 degrees plus 4 sec square 30 degrees minus tan square 45 degrees divided by sine square 30 degrees plus cos square 30 degrees. So let's go ahead and write their values. So I'll have 5 multiplied by cos 60 degrees. So cos 60 degrees is 1 by 2 square plus 4 sec square 30 degrees. So that would be 2 by root 3 square minus tan 45 degrees. So that is 1 square divided by sine 30 degrees. So that is half square plus cos 30 degrees. So that is root 3 by 2 square. So I go ahead, this would become 1 by 4. So it is 5 multiplied by 1 by 4 plus 4 multiplied by 4 by 3 minus 1 divided by 1 by 4 plus 3 by 4. Now the denominator becomes 1, so we can just skip writing it, and we will get 5 by 4 plus 16 by 3 minus 1. Now since my denominators need to be same, I will have to multiply them. So the LCM for 4, 3 and here the denominator is 1 would be 12. So I will get 5 multiplied by 3 upon 4 multiplied by 3 plus 16 multiplied by 4 upon 3 multiplied by 4 minus 1 multiplied by 12 upon 1 multiplied by 12, giving me the final answer as 15 upon 12 plus 64 upon 12 minus 12 upon 12, and it can be equated to, so if I do the subtraction, I'll get it as plus 3, so it would be 67 divided by 12, and that would be my final answer. That, my friends, was about the trigonometric ratios of some specific angles. That was 0 degrees, 30 degrees, 45 degrees, 60 degrees and 90 degrees. This is a really fun topic, and I would like to share it with your friends who find it slightly difficult. to understand. If you have liked the video, please hit the like button and subscribe to our channel and share it with those who need this video. I understand trigonometry is one of the most difficult topics. However, this is the easiest part in trigonometry. Always remember, you can always drop in at the Learners Academy. All you have to do is just Google search it and it will give you the directions. Also, we've given our link in the description. Please feel free to contact us in case of any doubts regarding mathematics or physics. This is Dr. Rishi from the Learners Academy signing off. Thank you.